Problem number 7 from engineering course sheet, in which you have to construct a epicycloid, which is a part of the cycloid family. In epicycloid, the circle is roll on the another circular path. So rolling circle of the diameter is 40 mm and the diameter of the directing circle is 140 mm. So first of all, you have to calculate theta. So theta is nothing but 360 degree into small r upon capital R. So this is the equation you have to remember for epicycloid. So 360 degree, small r is nothing but a radius of a rolling circle, which is 20 mm, and capital R is a radius of directing circle, which is 70 mm. So when you do calculation like 360 into 20 divide by 70, so you got 102.8 degree, which is equal to 103 degree. So by using this data, first of all you have to construct a line which is equal to the radius of the directing circle, which is 7, that means 7 centimeter. You have to take any random line with the 7 centimeter length. Okay, so by using you can draw anywhere, means at any angle, no issue, but by this is the length of 7 centimeter, which is 140 mm of the directing circle radius. Now put pointer over here and measure the angle of 103 degree from this. So if this is 100, so this is my 103 degree, and again you have to draw a line at 7 centimeter. Now use a rounder to construct a directing circle. So this is my directing circle. So my circle is passing on the means rolls on this circle like this. So first of all you have to construct this. This is 103 degree. Now you have to construct a circle, a rolling circle, which is 40 mm. Now you have to draw a circle on this path. So for that you have to extend this line little bit like this, and measure the distance of 20 mm. Measure the distance of 20 mm for the center point of the circle. So this is the 20 mm. Put your center over here, and this is your radius, and draw a circle. So this circle representing a rolling circle. So this is a rolling circle. Now same as we have discussed in cycloid, you have to divide this into 12 equal parts. So to divide it into 12 equal parts, you have to draw first of all 2 lines, which is perpendicular to each other. So this is the first line and this is the second line. Measure this distance as a 30, 60, 30 and 60. So this is a C point. Now as we have discussed in cycloid that you have to give label in this direction because your circle is rolling in this direction. So this is your first, second. Be careful with the labeling. Otherwise, if you put your numbering in that direction, then the whole circle means your epicycloid will be not constructed. Now we have to divide this arc into same number of parts which you have divided this circle, so 12. So you have to divide this into 12 equal parts, which is 103 degree divided by 12. So I think it's around 8.6. So to divide this into 12 equal parts, you have to multiply, see, simple, 103 divided by 12, which gives you 8.6 around, or 8.5. So you have to take 8.5, this is the degree, 8.5 degree into 2, so which is gives you 17. So first of all mark 8.5, then 17, then put this as a constant, means you have to make steady, then you have to multiply with the 3, so which gives you 25.5, so measure 25.5. accordingly you have to go up to 3, up to 12. So if you make up to 12, it gives you 102, which is our degree. So this is how you have to divide this circle, this arc, into 12 equal parts. So I have already divided like this. Then you have to join with the center lines with the origin like this. But I'll just make one more thing. You have to draw a center arc. So this O as a center and OC is a radius, and make an arc like this. Make an arc and extend this line up to that. So no need to do a second time. So this is my C1. Then draw C2. So complete these lines. So now this point is 1 dash, 2 dash, and the point from this line, this is the center line, right? So you have to write down C1 over here. This is the C2, C3, C4 likewise. Up to 12. Now draw arcs from each and every point of the circle from O as a radius, center. So if you draw an arc from 11, so it must be passing from 1 as well, like this, and you have to draw it up to end line. So this is 11 and 1, second one is 10 and 2, this is 10, 2, next is 9 and 3, 8 and 4, 7 and 5, and at the end 6. Like this. Now take small circle as a radius. So this radius, which is 20 mm, our circle is 40 mm diameter, so radius is 20 mm. Put your pointer on C1 point, C1, and make an arc on the line, on the arc which is passing from 11 and 1, like this. Same way, put point on C2, make an arc on the arc which is passing from 10 and 2, like this. Same way, C3, C4, put pointer on C4, make an arc on the line passing from 4, which is this. For 5, this is my arc. 6, last one is my arc. 7, again you have to go downward direction. This is 7, 8, 9, 10, 11, and at the end it is up to 12. Now give these points as a P1, this is P2, P3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now join all the points with a smooth curve, with a thin line. Like this. So this is your desired curve, but you have to make it dark. So this is your epicycloid. To draw normal and tangent, put point M on curve anywhere. Then measure this radius as a distance, M as a center, and make an arc on the curve. And this center line. So this point is M0. Joint with the origin or O point, like this. Wherever is intersect on the circumferential circle or the directing circle, this point is your N. Now join this N with M. So which is your normal, and perpendicular to this gives you tangent of the curve, TT dash. So this is epicycloid. A rolling circle is roll on the directing circle with normal and tangent.